Hello students, welcome to our very first lesson. As you can see, I'm already in OneNote and I am in the general information section. Just below that you see the calendar. So every day that you log in and need a lesson, you're going to click on the calendar. And you can see here I've already created a link for section 1.1. I will have a completed link for the lesson, which is the purpose of this video. That will be linked such that you can open it up in YouTube once it's created. And then there'll also be a link, as you can see, there is a link here for homework. Let me just go ahead and quickly click on 1.1 so you can see where that takes you. If you click on it, it's going to open up in Chapter 1, Section 1.1, wherein you can see a Word document that if you were to click on that, you can print it off if you'd like, and you can write on that. Or you can use your stylus after doing a copy and paste. So if I were to do a copy, and then I would probably want to hit no on that if I did a copy. And then you go to your name, and then under, let's say, class notes, you wanted to do a paste, you right click and paste. The notes are there for you guys if you'd like to write on with a stylus. I'm actually not necessarily suggesting that's the best way to do it. You certainly can. In my opinion, one of the best ways to take notes is just to kind of let the language, so to speak, speak for itself, and only write down examples on a separate sheet of notebook paper. So you're not actually writing or rewriting everything. Now, if you print it off, I guess you're going to be writing in the examples anyways, and obviously using the stylus as well. But those are just additional steps that you may not necessarily need to go through. All right, without further ado, I'm going to walk you through a version of how the notes are going to look when I present a screencast to you. So here's how it's going to work. So I've already completed the notes, and as you can see, all the notes below are completed and filled in. So I'm going to walk you guys through. This is again one version of how I'm going to present things. So here we go. Chapter 1, Functions and their Graphs. Section 1.1, Lines in the Plane. So we should already be fairly familiar with functions and their graphs, and more specifically lines. And frankly, Chapter 1 is more of a review than anything. But I still want to show you guys, obviously, one section pretty much at a time, how things are going to take shape. Warm you guys up to the content for sure. So what's the objectives? We're going to, you will know how to find the slopes of lines and use the slope to write and graph linear equations, and how to identify parallel and perpendicular lines. And we kick off here with the slope of a line. The slope of a line is the ratio of the change in y to the change in x. In addition, if we know 2 points on the line, x1, y1, and x2, y2, if you recall, this would be one ordered pair. And we use these subscripts, if you recall, just to differentiate x and y, but also one point versus another. And then, of course, x2, y2 for the second point. Then the change in y is y2 minus y1, or y sub 2 minus y sub 1, another way to say that. And the change in x is x sub 2 minus x sub 1. Therefore, the slope m of a non-vertical line through the 2 points is as such. So m equals y2 minus y1, the change in y, divided by x2 minus x1, the change in x. And I'm sure you remember that from Algebra 1, up until really now. Example 1. Find the slope of the line through each pair of points. So what I've done, I've already essentially assigned x1, y1, and x2, y2 to my ordered pairs. So if I maybe call this first point x1, y1, and the second point x2, y2, I can take y2 minus y1, so 3 minus negative 7, and notice I've also changed the signs to plus a positive, so 3 plus 7 that ends up being, divided by negative 4 minus 3, which you see there in the denominator. 3 plus 7, of course, is 10. Negative 4 minus 3, of course, is negative 7. Negative 10 sevenths, or 10 over negative 7. Now, the other way that I did it, I actually flipped my x1, y1, and x2, y2, and I end up with the exact same fraction. Negative 10 sevenths is obviously giving us a negative slope. You can, in fact, switch x1, y1 with x2, y2 and get the same result as I show. Part B. 2, -9, and -6, -9. So y2 minus y1, -9 minus -9, divided by -6 minus 2. In the numerator, -9 plus a positive and ends up being, well, -9 plus 9, so 0. And in the denominator, -6 minus 2, so -8. That, of course, is just 0. And of course, if you recall, zero slope implies that you have a line that has a line that has zero slope, or a horizontal line by nature. Part C. These two ordered pairs, 5, 4 and 5, -8. You can plug into, again, y2 minus y1, so I did -8 minus 4, and I did 5 minus 5. And numerator ends up looking like -12 while the denominator is 0. We hopefully recall that this is undefined slope. This is a vertical line by virtue of, again, if you were to plot these 2 points, you would see this take shape. So undefined slope. Moving on. The point slope form of the equation of a line. If x, comma y, we'll get back to x1, y1 in a moment, is any other point on a line that contains x1, y1 and has slope m, then y minus y1 over x minus x1, which is the slope still. Just notice that the subscript 2 are, in both numerator and denominator, are missing. Or, and if you guys consider the idea of simply cross multiplying, so if you cross multiply both sides, you get m times x minus x1 there in parentheses equals y minus y1. Hopefully this looks familiar to you. You may recall this is called the point slope form of the equation of a line. Again, something you learned in Algebra 1. So if we carry that down, as you can see on the next page, point slope form, an equation of the line through the point x1, y1 with a slope m is given as such. And in example 2, we'll go ahead and apply that exactly as you see it. Find the slope-intercept form of the equation of the line with slope 4 that passes through the point -6, 2. Slope-intercept form, as you recall, is y equals mx plus b. But to get to that form, we're going to use point slope. Point slope, again, knowing the slope, m equals 4, and the point x1, y1 is -6, 2. We plug it in such that it's y minus y1 or y minus 2 equals 4, the slope m times the quantity x minus x1 or x minus -6, which ends up being plus a positive 6. So this version right here would actually be sufficient if all I asked you for was point slope. We do have extra work obviously to consider because the directions again did ask for slope-intercept. And I'm going to take it one step further, even past that actually here. What I do from here is I can distribute the 4 such that y minus 2 equals 4x plus 24. I can add 2 and I end up with y equals 4x plus 26 as my slope-intercept. Y equals, in other words, mx plus b. Now there is an additional step that you may be asked to perform, and that is put it in standard form, or more specifically in this particular class, general form. General form is just a fancy extra step from standard form, wherein you take ax plus by equals c, and instead of equals c, you set it equal to 0. So in other words, you're going to move c on the same side as ax plus by. And again, ax plus by equals c, you learned way back in Algebra 1 again. So if we go this extra step, and this is to try to kind of front load what you're going to see later for sure, we can take this equation from the prior step and we can subtract y such that it's 4x minus y plus 26 still, and that equals 0. So you are going to run into problems where they're asking you for, they call it general form, and that's going to be something just to kind of take a look at down the road, getting you guys warmed up. All right, example 3. A company purchases a $20,000 machine. In 4 years, the machine will be worth $10,000. Now, if we're assuming that this is going down linearly as opposed to, let's say, exponentially, well, we're going to be able to write ourselves a nice linear function for this. And it actually says that here. It says write a linear equation that gives the value v of the machine after t years. So we're going to take the ordered pair 0 for time. 0 years have elapsed and it's obviously $20,000. After 4 years have elapsed, we're at $10,000. So if you use these two ordered pairs, and again the context of really what we've seen thus far with y2 minus y1 divided by x2 minus x1, so 10,000 minus 2,000 divided by 4 minus 0, we end up with negative 2,500. And because that's the slope, I can pick one of these 2 points. Frankly, picking the first point would be way easier as opposed to picking let's say the other point and or picking point slope form. But because I do want you guys to practice point slope form, and that's the nature of what we just kind of saw there in example 2 and up above that, let's plug it in to get practice. So v minus, so y minus y1, so minus 2,000 equals negative 2,500, again the slope, times the quantity t minus 0. It ends up really nicely unfolding into slope-intercept anyways, because as you distribute here, you'll only have negative 2,500 t, and as you add 20,000 over, you'll end up with this right here, v equals negative 2,500 t plus 20,000 for your final slope-intercept form. Again, if you had put it in slope-intercept form, or wanted to, I should say, from the get-go, you can just use this slope and this point, and you quickly and easily see y equals mx, m being this, plus b, 20,000 really being your y-intercept. And we're going to talk about that in a little bit again, but let's continue. Sketching graphs of lines. So speaking of that, and actually applying it correctly, consider the line given by the linear equation y equals mx plus b. So there you have it. By replacing x with 0, we see that the y-intercept of the line is 0, comma b. Note that 1, comma m plus b is also a point on the line. From this, we can see that the slope of the line is m, since a 1 unit change in x produces a m unit change in y. In other words, you can easily create the equation y equals mx plus b using those two ordered pairs. And you can go in the other direction as well. Instead of going right one up or down, you can go left one up or down. If the slope is positive versus negative, you'll see that kind of difference there. We'll talk about that in a little bit. So again, the graph of an equation of the form y equals mx plus b is a line with a slope m and y-intercept of 0b. This is called slope-intercept form. Example 4 asks you to sketch it. Now I actually used a little bit of the supplementary materials to help me here, or supplemental materials I guess you could say too. The y-intercept is 1. The slope is 2/3, so 0, comma 1, you'll plot a point with a slope of 2 over 3. In other words, you'll go up 2 and you'll go right 3. You'll plot a second point here, and 2 points is enough to create your line, and there you have it. This is the line y equals 2/3 x plus 1. Easy enough. Quick and easy review, I would say. In part B, y equals negative 2x minus 1, a y-intercept of negative 1, so 0, negative 1, you plot that point, and from there you go down 2 and right 1. And as you can see, those 2 points are enough again to create your line. Let's move on. Parallel and perpendicular lines. 2 distinct non-vertical lines are parallel if and only if their slopes are equal. That is, m sub 1 equals m sub 2. 2 non-vertical lines are perpendicular if and only if their slopes are negative reciprocals of each other. That is, m sub 1 equals negative 1 over m sub 2. Example 5. Find the general form, so ax plus by plus c equals 0, of the equation of a line that passes through this point and is parallel to, both parallel and perpendicular, to this line, 2x plus 3y equals 1. So before I kickstart the problem, I'll ask that we rewrite this equation in slope-intercept, which is simply me subtracting 2x, as you can see, and dividing by 3. So this equation is what we have for our slope-intercept. The slope is negative 2/3, the y-intercept is 0, comma 1/3. And then we can go through the process of using this point in context. Parallel again meaning same slopes, perpendicular again meaning opposite reciprocals. So the opposite reciprocal being positive 3/2 on this, while the negative 2/3 slope on the other. I am going to run out of time on these two problems, but I want you to take a look and see how they unfold. It will be a nice little beginning portion to your homework.